In today's lecture, see, last lecture we were studying about ransack algorithm. After that, we tried to morph this image with the given three codes, that is align, affine, and ransack pi. We did some transformations. We changed the threshold of everything, and we were able to invert the image using various filters. In today's class, we will be dealing with the artificial part of it. Suppose if I have to imply image classifications using artificial neural network. Okay, so before applying artificial image, the image processing over neural networks and classifying the set of images, let's examine neural networks properly. For example, what happens in a neuron? Suppose when we get a hurt, when we are hurted, what happens? A signal is sent from our brain to respond, and based on the intensity of the signal, the transfer of the signal takes place via the neuron. The neuron transfers the signal into the form of the synapse to the other neuron, and the processing continues until the synapse or the signal reaches the brain. So the structure of the neuron is as shown. See, the neuron has a soma, which has dendrites connected to it. Then from that you have axon, then synapses. This is the biological diagrammatic representation of the neuron. Now the information that is important includes that which is stored in the dendrites and the axon, because dendrites receive the signal from another neuron and the axon transmits the signal to the next neuron. Now this chain stops at the last node, which is the brain. So artificial neuron uses the same analogy and processes the information using artificial neurons. Okay, ANN, that is artificial neural network, will implement this process artificially into the coding. Now information is transferred from one artificial neuron to another, which finally leads to an activation function which acts like a brain and makes the decision. So you can say the expertise system is set using these techniques. The structure of the simple artificial neuron is as shown. See, now input, all the information which has to be processed is stored in the input node. Next comes the next layer, which is marked in blue, that is the hidden layer, where the information is actually processed, and the last is the output, which is shown in the green circles. Now the activation function is between the hidden layer and the output layer. Okay, we call this as a hidden layer because we cannot see what happens inside this hidden layer. There can be one or more hidden layer, okay, depending on the artificial neural networks layer. Now greater the hidden layer, deeper the network. Okay, if you have to do deep learning and all through machine learning, you have to increase this hidden layer. And see, sometimes it is normally I have seen back propagation and forward propagation of the program is normally done using this kind of structures. Okay, now we have to dwell with the complete details of the neural network. Now if we sit and talk about neural networks in depth, we won't be covering details of image processing. We have to start implying image processing through an ANN. We are not sitting to discuss about ANN. So whatever is required is given. Now suppose how to deal with it. We'll directly go to the application. Why are we using this? There is something called as handwriting recognition nowadays. Okay, normally it is done in banking. Your signature is matched with the your digital one is matched with the one which you have handwritten on. There are some formats and document they collect. Okay, based on that, what happens is you are using why are you using ANN came into picture? Because through that you did handwriting recognition. It is highly recommended that you should have a good base of ANN. Okay, so I suppose you know a bit of neural networks properly, how you write a sigmoid function, what is the weights, how you add the weight, what is activation function. थोड़ा सा background. Okay, Google it please. थोड़ा सा है, huh? Fine. So see, I don't want you to go in deep of it. What it is, you should know what is the basic structure you are working on, and that's all. So how will you try to imply? See, in today's lecture, what I did was, you have a big repository called as Modified National Institute of Standards and Technology. This is MNIST database. Okay, these database has approximately 60,000 training images. Okay, and 10,000 testing handwritten digits. And all. It doesn't have scripts, word script. I found handwritten digits only out there. So while using the training data set, see, it will look like this. The one which I took is looking like this one and this one. Okay, so now what is the idea behind this is, first you have to, you can make your own handwriting digit. Okay, you write it, scan it and create a JPEG of it. Okay, then write it you tilt your handwriting in some other way. First you write it in the format which you write, then make some minor changes, create another file. See, you can create your files. You can process your own files if you are interested, right? But you should have, that amount of patience to create. You should be able to create a difference between your own handwriting, or compare your handwriting with your siblings' handwriting. Okay. Now, upload. The flowchart for that is like this. You have to upload the data set, pre-process the data, find the training and the test set. Then same, after finding the training and the test set, you have to pass it through the input layer, the hidden layer and the output layer, because you have to call ANN features into IP out here. Now train the model, test the model and predict it. So first you have to go to this website, that is http Kaggle C digit recognizer hash data, and I downloaded it from there only. Okay, it will ask you to register. You register and download the required images you want. Fine. Now, after that, when you download it, you will have to pass it through the thing. Now, if you look at it, this kind of images you will get inside that. You have to actually call the CSV. You will get a CSV. You have to call that CSV into the program. So how will you call that CSV is, you have to first write import pandas.pd, then input underscore data pd read CSV, and you have to send that CSV which you have downloaded. Download hua aapka? Okay. So write this, import pandas.pd, input pd read CSV, train CSV. See, now you have to create 2 data frames. Okay, because take a look of the training set. It consists of 785 columns. Each image has a resolution of 28 into 28. Okay, therefore it has 784 columns contain the pixel value of each digit. The last digit indicates the actual number represented by the values. Let's take a look of the images. See, this is the first MinSet data set and this is the second one. Now you have to create 2 frames in Python. One will store the pixel of X value and other will store the actual number. Okay. So Y input label, input data drop label axis 1 in place true, and X input data. Now what we have to do is, the idea is we have to convert the labels into present in Y into dummy. So for that you have to pass it using this syntax, y is equal to pd dot get underscore dummies y. Now that we have the data in X and Y, we should start our network. Which network? The neural network. So let's create 4 hidden layer, 1 input layer and 1 output layer using Keras. So you have to write it like this, classifier is equal to sequential. Fine. Now classifier dot add dense units 600 kernel initializer uniform. Okay. So you are creating how many? You are creating 4 hidden layers, 1 input layer and 1 output layer. Okay. So this is the idea. Using this, you will create the classifiers one after the another. Okay. Now, in the first hidden layer, you are passing 600 neurons. The second, you are passing 400 neurons. The third, you are passing 200 neurons. And the last, you are passing 10 neurons. Okay. We initialize the parameter W and B in the normalized format by giving kernel initializers uniform. In the first 3 layers, we get the activation function ReLU. The last consists of sigmoid function. See, first 3 you have activation using this ReLU command, and after when you want to collect the output, you are passing it through sigmoid function. Okay. So, now the first, see why you did like that? Because we have a dimension of 784, fine. That's why we needed so much of neurons and so much of layers. Okay. Now, the dissipated network, the network which we made would look like this, fine, with the activation sigmoid signal. After that, you have to train the classifier. Okay. For that, you will write this classifier.compile optimizer SGD loss mean squared error matrix accuracy, and then by start the training. Okay. Classifier fixed X train, Y train, batch size 10 and 10 epochs. So the accuracy goes up to 95%, and see, this is the output which I got after that. So shall we do this? If you want, then you have to write that test data PD in the test.csv, we can store it. This is the full code. Add capital, you have defined the classifier earlier, kind of type of the layer is dense, unit equals to 600, comma, kernel underscore initializer, write it properly because you have to write this thrice, initializer equal to uniform, okay, then comma, activation using what? What is your activation function you are using here? Yes, you are using 2, ReLU and sigmoid. And what was the input dimension which we selected? I had an image which has 784, so I am passing it that only. Even if it is big, the frame will be set up to 784. Okay. So, input underscore dimension equal to 784. Okay. Close the bracket. Now, copy this. What you will be changing here? You will be changing the number of units you are passing. Okay. And in last, you will be changing the function, activation function. Okay. So, in this way, what you are creating? Yes. What did you create now? You created the 4 which layers? Hidden layers. Okay. There may be many ways of writing, see, but this is something I found easier. See, don't write input for everything. Once you have passed the input, remove this part from all the others. Okay, you don't need input every now and then. Once you have defined, it's okay. In the main one, remove this input part from all the other coding. Okay, now pass the activation as sigmoid in the last function. Okay, fine. This will complete your classifier. Fine. Now you have to compile that classifier. So enter this and CLASSIFEI. So what did you do? You created everything. Now you will write for the code for compiling the classifier. What you will do? Classifier dot compile. Fine. Compile. Now you have to optimize it to run to the limit you have passed. What you wanted? You wanted one input layer, 4 hidden layers and one output layer. So you have to optimize it. So you will be optimizing it. You have to write optimize. Oh my god, I do a lot of writing error. Optimize. Yeah, let it be. Optimizer equal to SGD, okay, comma, what about the loss? Who will take care of my losses? Mean underscore squared 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 underscore, okay, error. Then you have matrix equal to ACC accuracy, okay, write it in quotes. Fine. Okay. Now, हाँ कोड्स करना है, उसको कोड्स कंप्लीट नहीं हुआ, सॉरी, थैंक यू. Fine. Okay. Now classifier dot fit fits x comma y, the one which you have defined. Then the batch size कितना डाला last में? You have just passing a batch size of 10. Okay, comma epoch equal to 10. Okay, where are you passing all these? On to test underscore data equal to pd dot read underscore csv test dot csv y underscore pr spread equal to classifier dot predict test underscore data. Okay, so this ends your code. Now we'll run and see it. Just started. It will go up to size 10 epochs because you have passed a batch size of 10, and it will stop. Okay, see this 10 by 10. It will start from 1 to 10 and it will stop. It will classify and stop. Can you compare other two? You can take any other two data, try to compare, or else create your own data set. Fine, create your own training and create your own test and pass it and try to find out this.
Okay, try to find out the changes, try to find out the comparison accuracies using ANN. Okay, and in CNN, the style of writing, the model will change. It will change a bit. Should I close it?